well, it's getting better now with early intervention, but at one point it was about half of all kids with autism who never developed functional language. Serious problems in what's called social reciprocity, making eye contact, reading social signals and being able to use those to communicate with other people, all very difficult for people with autism. And so I was studying their language, trying to identify strengths and weaknesses across different language domains. So conversation, narrative, storytelling, standardized language tests, and then drawing ties between these profiles and what we hypothesized were underpinning neurocognitive abilities. So social cognition, executive function, these are cognitive domains that have been hypothesized to explain many of the features associated with autism. And what we found were that the deficits observed in autism in the language domain were highly related to their problems understanding social stimuli, so problems in social cognition. And it makes sense, if you have trouble reading someone else's thoughts and feelings, you're going to have a really hard time engaging in a fluent conversation with them, which requires, inferring background information. So what is this person coming to the conversation with? Do I need to provide background so that they know what I'm talking about? It also involves reading someone's thoughts and feelings to gauge whether they're interested or are they following me? Do I need to provide more information? So all of these social cognitive skills are critical in language learning and language functioning. Then I did postdoctoral research focusing on parents of people with autism, studying what's called the broad autism phenotype. There's strong evidence for autism being a genetically based disorder, but the likelihood is that there are many genes that contribute to autism, and maybe different constellations of genes in different families. So it's a real challenge. One way to meet this challenge would be to focus on traits, or phenotypes we call them, these features that may be linked to more basic sets of genes, smaller sets of genes. Then we collect a blood sample. That's what these are for. And we send it over to the biospecimen facility here at UNC, where they store it. Well, first they extract the DNA for us and store it. And then the next step of the study will be to actually look and see whether there's genetic variation related to how they're doing on these tasks. So Fragile X we know the gene. It's identified, and we know the patterns of transmission. So all moms of a child with full mutation Fragile X will be carriers of the gene in its pre-mutation state, unless they have Fragile X themselves, but that's not too common. And so, I should take a step back. We see incredible overlap in autism and Fragile X, where anywhere from like 30 to 50% of kids with Fragile X are also diagnosed with autism. So this leads us to believe that this gene may play a role in autism symptomatology. So thus the interest in Fragile X, which is also just a really interesting population in itself. So they focus on kids with Fragile X, kids with autism and Fragile X, and kids with Down syndrome who are in there as a control. And we're looking for across different language domains, so pragmatic language, structural language, and then these social cognitive skills, theory of mind. Where is there overlap between Fragile X and autism? Really just trying to refine our understanding of the phenotypic profiles of these groups, so that we can then infer the role of this candidate gene, FMR1, in autism symptomatology and particular features in Fragile X.
When you look at this, what does it look like?
A rock.
Feel it. What is this really?
Sponge.
It's a sponge, but when you look at it, what does it look like?
It looks like a rock.
Great, that was it.
The ability to distinguish reality from appearance is one of the precursor skills to theory of mind.
What do you think is in this box?
Candy.
Let's look inside and see.
Oh,
What is it really?
Buttons.
Let's see. Emily saw this box earlier. What do you think she thinks is in the box?
She's gonna think that there's candy in the box.
And then we would have her come in and look and be like, "Oh, let's see what she thinks." Buttons.
Now, if I were a child who didn't have theory of mind, I would have said, she's gonna think that there's buttons in there.
Yeah.
It's this ability to differentiate your own informed state of mind from someone's naive state of mind that we're getting at here. And you'll see by about the age of 5, typically developing kids can pass this test without problem. But you'll see,
Like 3-year-olds. We've done a few 3-year-olds that don't get this, but they get the other tests. So.
But an older person with autism, or maybe with Fragile X, would have difficulty with this test. I would say if you're interested in research with language disordered populations, I think find a professor who's doing the kind of research that you're interested in, or working with a population that you're interested in, and ask if they'd be willing to meet with you. And I think if you can find an opportunity to volunteer in a lab to actually get research experience with them, it's invaluable. That was how I started, and it's nice to know early on that whether or not you're interested in research, and that's the best way to do it. It's also essential to have that sort of experience if you want to go to graduate school.